Hello everyone, I am Sri Harshavinay from Gokaraju Rangaraju Institute of Engineering and Technology, belonging to Department of Electronics and Communication Engineering. Coming to my project name is Smart Traffic Management System using YOLO V4 and MobileNet V2 Convolution Neural Network Architecture. My batchmates are Varun and Siddhartha. We are going to see introduction, literature survey, problem statement, objectives, existing work, proposed methodology, results and observations, and conclusion. Coming to introduction, congestion owing to traffic is one of the crucial complications in urban cities, which is need to be addressed to improve traffic control and operation. This design proposes a novel smart traffic system that utilizes real-time average vehicle area and emergency vehicle detection to optimize traffic flow and improve emergency response times. This system employs YOLO V4 and MobileNet V2 convolution neural network pre-trained model to accurately detect the number of vehicles present on the road, average vehicle area, and identify emergency vehicles in real time. Using this information, this system can dynamically adjust traffic signals and reroute vehicles to minimize congestion and ensure priority access for emergency vehicles. Experimental results show that this system significantly reduces average travel times and emergency response times, making it a promising solution for modern traffic management and emergency services. Coming to problem statement, congestion in traffic is a serious problem nowadays. It is ever increasing nature makes it imperative to know the road traffic density in real time for better signal control and effective traffic management. There can be different causes of congestion in traffic like insufficient capacity, unrestrained demand, large red light delays, etc. While insufficient capacity and unrestrained demand are somewhere interrelated, the delay of respective light is hard-coded and not dependent on traffic. Coming to the objectives, the research objectives related to the traffic congestion and emergency vehicle management can be outlined as follows. First one, develop a robust and accurate vehicle detection system using YOLO V4 to detect and track vehicles in real time. Second, train a MobileNet V2 CNN model to identify emergency vehicles such as ambulances and fire trucks with high precision and recall rates. Third, implement a vehicle density calculation algorithm based on average vehicle area to determine the density of vehicles in specific regions or lanes, providing insights for traffic design and management. Fourth, determine the number of vehicles detected by utilizing the vehicle detection capabilities of the YOLO V4 and MobileNet V2 models, enabling accurate counting of vehicles in a given area. Fifth, design an emergency vehicle detection system using MobileNet V2 to identify and classify emergency vehicles, enabling efficient emergency response and prioritized traffic management. Sixth, develop a traffic light decision making algorithm that takes into account real-time vehicle detection, emergency vehicle detection, vehicle density information, and traffic flow data to optimize traffic signal timings, minimize congestion, and improve overall traffic efficiency. The existing approach or the current approach is where the system captures the image, converts to grayscale, and enhances the image, thresholds and foregrounds, and counts the vehicles and allocates some time. So by this approach there are some drawbacks. So we are going to implement a new approach. This is our proposed methodology where we give a video, or the system captures a video, and then each frame goes to YOLO v4 code based on COCO data set. Then each vehicle is detected by a bounding box and labeled with the type of vehicle. Now, if the labeled vehicle is bus or truck, then the segment out each vehicle based on the bounding box. Then each segment vehicle is given MobileNet V2 CNN model. This model classifies whether the vehicle is an ambulance or a fire engine. So in this also there is a chance that can be a bus or a truck or an ambulance or a fire engine, that are also classified in this one. So if it is not a bus or a truck, then number of vehicles detected and total area of vehicle in each frame will be calculated, and average vehicle area is calculated depending upon the bounding boxes, and then the average vehicle area of one lane is compared with other lanes. Then uh, we will know that which side has more traffic. By this the green light is lit for more time. Coming to implementation, this methodology presents smart traffic management combining YOLO v4 and MobileNet v2 to handle dense, heavy traffic and recognize emergency vehicles. The functionality of this system is broadly classified into three parts. They are: input acquisition and vehicle classification section performs input image processing using the OpenCV module in Python and classifying the type of vehicles detected. Classification of emergency vehicle section performs further classification of vehicles for the detection of emergency vehicles. Computation of the average vehicle area section calculates the average vehicle area which is used to parameter for the decision of traffic light. The MobileNet V2 CNN model. The MobileNet V2 CNN model is obtained by creating a dataset of 4 classifications: bus, truck, ambulance, and fire engine. Each classification consists of 576 images. Out of this training dataset is 75% and the validation dataset is 25% of the total images. The target size of the image is set as 224 by 224. MobileNet V2 architecture is used for training this data, and activation layer is a sigmoid layer. The model was trained over 10 epochs and the final validation accuracy is 95.49% and the validation loss is 0.1818. So here you can see the block diagram of creating MobileNet V2 CNN model. Dataset will be there, and then splitting the data into training and testing dataset, and then we will give the data to the MobileNet V2, then train the CNN model. Then this model gives us the output depending upon the inputs. So this is how the bounding boxes will be formed for the images that are framed from the video. So here you can see a car, ambulance, car, and car. So with a density value. Here you can see this is a fire truck, and that is a bus, and there is a car, and there is another car. These bounding boxes will be taken and calculated the average area depending upon the bounding boxes. Then the overall area will be calculated. Then the density can be calculated. So with the area and density, we can evaluate that which side is more traffic and which side is less. Depending upon this, we can lit green light for more time, and we can give way for the ambulance and fire truck. Coming to results and discussions, we have used 8-layered experimental CNN model. Initially, a CNN model with 8 layer instead of a MobileNet V2 CNN model was experimented. This 8-layered CNN structure consists of two convolutional layers, two max pooling layers, one dropout layer of 0.5, one fattening layer, and the last two fully connected layers, out of which one has activation functions as ReLU and another as a sigmoid. The validation accuracy of experimented 8-layered CNN model is 69.79%, and the validation loss of the performance of the CNN model is very low, with low validation accuracy and high validation loss when compared to the MobileNet V2 CNN model. Here you can see the performance matrices of 8-layered CNN model. The validation accuracy of experimented 8-layered CNN model is 69.79%, and the validation loss of 1.4518, whereas the MobileNet V2 CNN model has 95.49% validation accuracy and the validation loss is of 0.181. This is the performance matrix of a MobileNet V2 CNN model. This is a validation accuracy and a validation loss. Coming to conclusion, the system focuses on realizing a model that not only works for minimizing traffic issues but also aids the passage of emergency vehicles as soon as possible. The presented paper aims to increase cost effectiveness and accuracy and reduce the complexity involved in traffic systems by giving preference to emergency vehicles. The proposed model intends to achieve a smart traffic system that can be used for modern day optimal traffic monitoring. These are the references, and thank you.